Good day, everyone. It's another beautiful day for studying and learning science, physics in particular. I hope that you will be able to attain the objectives of this presentation. In our session today, we are going to study about measurement of physical quantities. Nearly in everything we do, measurement is involved, be it qualitative or quantitative measure. If you were asked to measure the length of this table, how will you do that? You need an instrument to determine the table's length. The same in measuring the width and the height. You will need a meter stick or a ruler or other length measuring device. In this example, the table's length is an unknown quantity while the length of the meter stick is a known quantity. We have to compare the length of the table to the length of the meter stick. The number of the lengths of the meter stick contained in the table's length is the length of the table. The same is true with the height and the width of the table. The process that we do is known as measurement. How about the mass of this huge boulder? To determine the mass of this boulder, we have to compare its mass to a standard kilogram. In measurement, how is the measure expressed, or what made a measure? A correct measure contains a number and a unit. The number denotes the ratio between the unknown quantity and the known quantity, and the unit serves as the means of comparison. For example, if the length of the table is 2.5 meters, that means the length of the table is 2.5 times the length of the meter stick. The unit meter serves as the means of comparison between the length of the meter stick and the length of the table. The measure can be expressed as an actual measure. For example, the mass of the Earth in its actual measure is 5 octillion 972 septillion 200 quintillion grams. We can also use exponential notation in expressing the measure. That the mass of the Earth is 5.9722 times 10 raised to the 27 grams. We can also use the SI prefixes. That the mass of the Earth is 5.9722 times 10 raised to the third power yottagrams, or 5,972.2 yottagrams. Physical quantities can be classified as either basic or fundamental, and a derived quantity. Now, how do they differ from each other? The difference is in the way the measures of these quantities are obtained. The basic or fundamental quantities. There are 7 basic or fundamental quantities, namely length, mass, time, temperature, amount of substance, electric current, and luminous intensity. The measures of these quantities are obtained using a specific instrument, and its quantity is independent of each other. Some of the measuring devices for length are ruler, meter stick, burner caliper. For mass is a beam balance, be it an equal arm or triple beam. For time, wristwatch, stopwatch, pendulum. For temperature, thermometer. For the amount of substance, there is no recorded device for determining the number of moles of a substance. Thus, the number of moles is often computed. But in the macro sense, some amount of substance devices are tablespoon, teaspoon, cups. For electric current, ammeter. And for luminous intensity, photometer. Some units of these basic quantities are: for length, meter, inch, kilometer, feet, miles. For mass are grams, kilogram, slag, ounce. For time are second, minute, hours, day, week. For temperature are degree Celsius, degree Fahrenheit, Kelvin. For the amount of substance, mole, teaspoon, cup, pinch. For electric current, ampere, milliampere. And for luminous intensity, candela, lumen, and lux. How about derived quantities? Derived quantities are the physical quantities obtained by combining basic quantities. Other derived quantities are even a combination of basic and derived quantities. In this table, samples of derived quantities are presented. The definition, equation, unit, and basic unit equivalent are presented. Area is a derived quantity defined as the product of two lengths, and the unit is the product of the units of length, meter squared. Volume is defined as length times length times length. The unit is cubic meter. Density is defined as mass per unit volume. The equation is rho equals m over v, and the unit is kilogram per cubic meter. Velocity is a derived quantity which is the ratio between a length and a time. The formula is v equals L over t, and the unit is meter per second. The acceleration is also a derived quantity with basic quantity equivalent of length divided by time divided by time. And the basic unit equivalent is meter per second squared. Force is a derived quantity defined as the product of a basic quantity mass and derived quantity acceleration. The force unit is Newton, in honor of Sir Isaac Newton, with basic unit equivalent kilogram meter per second. There are two conventional systems of measure, namely the English and the metric systems. The English system is also known as the imperial system. Some units of length in the English system are the inch, feet, yard, mile. Some units of area in this system are acre, square inch, square foot, and square yard. Some units of weight in this system are ounce, pound, stone, and ton. Some units in this system are fluid ounce, pint, quart, cubic inch, and cubic foot for volume. The table also presents the conversion of measures between units in this system, like 1 inch is equal to 1/12 of a foot, and 1 stone equals 14 pounds. Metric system. Metric system is also known as the decimal system. It uses the power of 10 notation in expressing the measures. Converting units in this system is quite easy because it's done by multiplying or dividing the measure by the powers of 10. The table of SI prefixes and meanings presents the prefix, the symbol, the value, and the meaning of the prefix. The prefixes higher than the base unit includes iota with the value 10 raised to 24 and means septillion times the base unit. Zeta with the value 10 raised to 21 and means sextillion times the base unit. Hexa with the value 10 to the 18 and means quintillion times the base unit. Peta with the value 10 to the 15 and means quadrillion times the base unit. Tera with the value 10 raised to 12 and means trillion times the base unit. Giga with the value 10 raised to the 9 and means billion times the base unit. Mega with the value 10 to the 6 and means million times the base unit. Kilo with the value 10 to the third power and means 1,000 times the base unit. Hecto with the value 10 to the second power and means 100 times the base unit. Deca with the value 10 to the first power and means 10 times the base unit. The prefixes with lower values than the base unit, the values and the meanings are also presented in this table, namely the deci, the centi, milli, micro, nano, pico, femto, atto, zepto, and yocto. These SI prefixes values serves as the conversion factor with converting a measure from one unit to another. Some examples are presented later in this video. Measures can be converted from one system to another, say English to metric or metric to English. The conversion is done using factors between these systems. Example, to express a unit measured in inches into millimeter, multiply the measure in inch by 25.4 millimeter. This means 1 inch equals 25.4 millimeter. Another, to change the unit from square feet to square meter, multiply the square feet measure by 0.09. This shows that 1 foot square equals 0.09 meters square. How about metric to English? Say, kilometer to miles. To change the unit of length from kilometer to miles, multiply the measure in kilometer by 0.6. In performing activities about converting units, it's a good idea to keep a table of conversion within the same system or across the systems at hand. In converting a measure from one unit to another, a conversion factor is necessary. The given measure with the given unit should be multiplied with the conversion factor to obtain the measure with the required unit. Example, 1 kilometer equals 10 to the third power meter. This means 1 kilometer divided by 10 to the third power meter is equal to 1. And 10 cubic meter or 10 raised to the third power meter divided by 1 kilometer is also equal to 1. So multiplying the given measure to the conversion factor is similar to multiplying a number by 1 where the value of the measure does not change. This time, we'll have an example of conversion of measures within a system and across system. This is the first example. A civil engineer constructed a 12 kilometers road from town A to town B. What is the length of the road connecting town A and B in A meter, B megameter, C feet, and D miles? We have to analyze the problem to obtain the information provided. The quantity involved in the problem is length. So keep in mind the units of measures of length. The measure of length given is 12 kilometers, which is the length of the road from between towns A and B. It involves the prefix kilo. And now, what are the unknowns in the problem? The unknowns are meter, megameter, feet, and miles. So, knowing all the information provided in the problem, we can solve the problem. So, to express the measure with the required unit, we need conversion factors. Now, let's do the conversions one by one. So, in letter A, we are required to determine the equivalent of 12 kilometers in meters. So, in this case, the conversion factor needed is 1 kilometer equals 10 to the third power meter. Now, let's substitute and calculate. The length equals 12 kilometers, the given, times the ratio of 10 to the third power meter and 1 kilometer. This ratio is equal to 1, thus the value remains the same. The unit kilometer, when divided by another kilometer, cancels the other. So the ratio is equal to 1, thus the value remains the same. So when the calculation is done, the result is 12 times 10 raised to the third power meter. In letter B, the requirement is to convert the 12 kilometer to megameters. In this case, two conversion factors are needed except when we obtain the direct conversion between kilometers and meters. The conversion factors are 1 kilometer equals 10 to the third power meter and 1 megameter equals 10 to the 6th power meter. Now let's substitute and calculate. The length equals 12 kilometers, the given, times the ratio of 10 to the third power meter and 1 kilometer times the ratio of 1 megameter and 10 to the 6th meter. These ratios are both equal to 1, thus the value remains the same. The unit kilometer when divided by kilometer and meter divided by meter cancels each other. So when calculated, the result is 12 times 10 raised to the third power meter. In letter C, the conversion is from metric to English. The requirement is to convert the 12 kilometer length to feet. In this case, two conversion factors are needed unless we obtain first the direct conversion between kilometer and feet. So the conversion factors are 1 kilometer equals 10 raised to the third power meter and 1 meter equals 3.3 feet. Now let's substitute and Calculate. The length equals 12 kilometers, the given, times the ratio of 10 to the third power meter and 1 kilometer, times the ratio of 3.3 feet and 1 meter. These ratios are both equal to 1, thus the value remains the same. The unit kilometer cancels kilometer when they are divided, and meter divided by meter cancels each other. So when the calculation is done, the result is 39.6 times 10 raised to the third power feet, or 3.96 times 10 to the fourth power feet. In letter D, the requirement is to convert the 12 kilometers length to miles. In this case, the conversion factor needed is 1 kilometer equals 0.621 miles. Now let's substitute and calculate. The length equals 12 kilometers, the given, times the ratio of 0.621 miles and 1 kilometer. This ratio is equal to 1, thus the value remains the same. The unit kilometer when divided by kilometer, the result is 1, thus cancels each other. So when the calculation is done, the result is 7.456 miles. Okay? Don't forget to write your final answers based on what are required in the problem. So in this problem, the answers are A. Length equals 12 times 10 raised to the third power meter. B. Length equals 12 times 10 raised to negative 3 megameter. C. Length equals 3.96 times 10 raised to the fourth power feet. And D. The length is 7.456 miles. Now, what does these values of lengths mean? It shows that 12 kilometers when expressed using other units changes the number but the value remains the same. That 12 kilometers equal to 12 times 10 raised to the third power meters equal to 12 times 10 raised to negative 3 megameter equal to 3.96 times 10 raised to the fourth power feet and is equal to 7.456 miles. The next example is involving a derived quantity. The problem is, a car is traveling at a speed of 27 meters per second. What is the speed of the car in A. Kilometers per hour, B. Feet per second, and C. Miles per hour? In this problem, when analyzed, the quantity given is speed, and the measure of speed is 27 meters per second. The unknowns required in the problems are the speed of the car in kilometers per hour, feet per second, and miles per hour. So in letter A, the car's speed in kilometers per hour is the required or the unknown. Between the given speed of 27 meters per second and the unknown kilometers per hour, the conversion factors needed are 1 kilometers equals 10 to the third power meter and 1 hour equals 3,600 seconds. Now substitute and calculate that the speed equals 27 meters per second times 1 kilometer over 10 to the third power meter times 3,600 seconds divided by 1 hour, where the conversion factors are all equal to 1. Thus, the value will not change. And when calculated, the speed of the car is 97.2 kilometers per hour. So, with this result, that 27 meters per second is equal to 97.2 kilometers per hour, how many kilometers per hour are there in 1 meters in 1 meter per second. Okay, this will serve as one of your assignments. Now, let's proceed to letter B. So, in letter B, the required is the speed of the car in feet per second. That between the speed of 27 meters per second and the unknown feet per second, the conversion factors needed is for the length, meter to feet, that 1 meter equals 3.37 feet. Okay, so we need only one conversion factor because we are only converting the length measure. Substituting the given speed of 27 meters per second and the conversion factor 3.37 feet over 1 meter, the unit meter cancels out. When multiplied, the result is 88.58 feet per second. Letter C, what is required is the speed in miles per hour. So between the given speed of 27 meters per second and the unknown miles per hour, we need three conversion factors. Namely, 1 kilometer equals 10 raised to the third power meter. 1 kilometer is also equal to 0.621 miles. And 1 hour equals 3,600 seconds. Substituting the given speed of 27 meter per second and the conversion factors, 1 kilometer over 10 raised to the third power meter, 0.621 miles over 1 kilometer, and 3,600 seconds over 1 hour. When multiplied, the result is 60.36 miles per hour. With this result, the 27 meter per second is equal to 88.58 feet per second and 60.36 miles per hour. And in letter A, 97.2 kilometers per hour. How many feet per second are there in 1 meter per second? How many miles per hour are there in 1 meter per second? And how many miles per hour are there in 1 kilometer per hour? So these are additional questions for your assignment. Now, after these examples, now let's test your understanding. So, how much have you learned or have you attained the objectives in this presentation? Okay, employing the concept of measurement and the conversions you learned. So, this is the problem. The mass of a proton is 1.67 times 10 raised to negative 27 kilogram. What is the mass of a proton in milligrams? B, yotagram, and C, pounds. So in this test, I want you to identify the quantity, the measure, the unknowns, the conversion factors needed to solve the unknowns, and the final answer. So you are provided with 3 minutes to solve this problem. And your 3 minutes starts now. Okay, class, your 3 minutes is over. Now let's check your work. Hope that you got the correct answers. Okay? The given in this problem, so the quantity is mass. And the measure of mass is 1.67 times 10 raised to negative 27 kilograms. Now, how about the unknown or the required? Okay, so mass equals blank milligrams. The mass in yotagram and the mass in pounds. The conversion factors required to solve or to convert the measure from kilogram to the required units. For letter A, 1 kilogram equals 10 raised to the third power grams. 1 milligram equals 10 to negative 3 grams. So for letter B, 1 kilogram equals 10 to the third power grams and 1 yotagram equals 10 to the 24th power grams. In letter C, 1 kilogram equals 2.2 pounds. So, substitute and calculate, and then let's check your final answers. Final answers for letter A, the mass equals 1.67 times 10 raised to negative 21 milligrams. Letter B, the mass is 1.67 times 10 raised to negative 48 yotagrams. And letter C, the mass is equal to 3.68 times 10 raised to negative 27 pounds. Okay, so I hope you got all the correct answers. So this test is converting measure for a basic quantity. Now let's have test for conversion of derived quantity. So in this problem, the density of a known substance is 7,874 kilogram per cubic meter. What is the density of the same substance in gram per cubic centimeter, B kilogram per liter, and C gram per milliliter? Okay, so just the same as the first problem, I want you to identify the quantity, the measure, the unknowns, the conversion factors, and give your final answer. Again, you are given 3 minutes to complete the answers to the problem. And your 3 minutes starts now. Okay, class, the 3 minutes is over. Let's check your answers. So in this problem, the given quantity is density. The measure of the density is 7,874 kilogram per cubic meter. What are the required or the unknowns in the problem? So A, the density in gram per cubic centimeter. B, the density in kilogram per cubic liter. The density in kilogram per liter. And letter C, density in gram per milliliter. The conversion factors to solve the problems. Okay, so for letter A, 1 kilogram equals 10 raised to the third power gram. 1 centimeter is 10 raised to negative 2 meters. So for letter B, 1 cubic meter equals 10 raised to the third power liters. And letter C, 1 kilogram equals 10 to the third power gram. And 1 milliliter is 10 raised to negative 3 liters. So, substitute and calculate. And then now let's check your final answers. In letter A, the density is equal to 7.874 gram per cubic centimeter. Letter B, the density is 7.874 kilogram per liter. Letter C, density equals 7.874 gram per milliliter. Now, what can you say about the values of the densities in the required units? So, are they of the same numbers even though they are of different units? Now, what does that mean? So, that only shows us that the units gram per cubic centimeter, kilogram per liter, gram per milliliter are equivalent units. Okay, did you get the correct answers? Okay, I hope that you have learned what you are supposed to be learned in this topic. Okay? That's all for this topic. Thank you for viewing this video. I hope you learned and meet the objectives for this lesson. If you learned from this video and find the video interesting, don't forget to like and subscribe for more learning videos. Thanks and good luck.